So MCP just shipped its biggest update of 2026, actually the biggest rewrite since the protocol launched. And it really is a fantastic one. This video is for anyone who touches the world of MCP, whether you're a consumer, a builder, or an enterprise. So here's the plan for today. I'll break down exactly what it means for you, whether you write code or you have never touched a terminal in your life, no problem. And we will then prove it using my product. So what I did was I created a website with my YouTube channel analytics, but the data is actually in BigQuery. I've created actually two MCP servers, one using the old protocol and the second one using the new protocol. So what we will do is we will let AI talk to both of these servers and we will see exactly what happens turn by turn, machine by machine, and cost by cost. First, a 10-second picture so that we can understand and we can ground ourselves, right? So you know those connectors you attach your AI agents. So for example, like vidIQ for getting YouTube channel statistics, or Notion, or Obsidian, or even your calendar, Google Drive, right? Behind every single one of them sits a small program called an MCP server. Your AI sends it messages and the app answers back through it, through the MCP. Now, that is not the only way, obviously, an AI can talk to an app, but it has become quite the standard way. And that conversation between the AI and that little program is what got rewritten today. Three main changes. Number one, the conversation went stateless. What does that mean? Unless today the server had to remember every AI it was mid conversation with. Think of it like a phone call, it could not hang up. Now, every message arrives complete. There's nothing to remember. And that one change lets MCP servers scale like normal websites. Number two is a brand new trick called multi-round trip request. When a tool is about to do something serious, let's say delete a file or spend money, it can now pause mid-task and check with you first. And three, these messages now travel dressed like normal web traffic with the label printed on the outside. So the load balancers and the firewalls companies already own can finally manage AI traffic like any other traffic. All right, so before we get there, a quick disclaimer, all opinions are my own and do not belong to my employer. All right, with that, let's get into it. So let me explain you the demo scenario over here. So what you're seeing on the screen now is an app that I built based on my real YouTube channel, which is over here. And what I did was I exported all of this data in a database. In this case, I've used BigQuery. So you can see all the data about my real videos and all the information is actually here, right? So you can see that it has got details about the number of views and all of those kind of things, right? So just at a high level, it is real and this is a real app. Now, why do we use MCP? So for example, if I want to make this app available for any AI agent to access and get information from this app, that is where I would be building an MCP server. So I did that, but I did two of that, right? So I built an MCP server using the protocol definition before today, and I built an MCP server with the protocol definition from today, which is the latest one. And what I want to show you is how an AI agent will behave when it interacts with the first one versus the second one. Okay. Just to make sure that this works, I also built an ADK agent, Google's agent development kit, what you're seeing on the screen right now. So I'm just going to ask, hey, can you tell me my top 3 videos with the highest views? Now you would see that this ADK agent is spinning up and you can see that it is going through the MCP server and it has done the job, and you can see it is actually like providing the information live. And I can see also through the visuals and stuff like that, these are my top 3 videos, right? So this is the ADK agent. You can see it is working live. And if I go to my channel, you can also see the same 3 videos which are listed, right? 78K, 69K, 47K, etc. This is the version where ADK is interacting with this. Now, it is going to be very difficult for me or anyone to explain how the interaction between an AI agent and the MCP server happens and what changes. Because remember, the application will try to abstract it from us, right? From you and I. All right. So to explain this, what I did was I created this specific MCP inspector where I will show you the difference between what is happening under the hood when we are using the old version of the protocol versus the new version of the protocol. The intention is to make it absolutely clear to you. So let's say that an AI agent or AI assistant or whatever is the client is going to ask this particular question, right? What is my most viewed video? Now you see these four instances of four different machines. So think of this as different machines deployed in cloud. It could be AWS, it could be Google. So you also see this, there's a client scaffolding on, right? So the idea here is whenever an AI asks a question, it depends on the application owner to figure out and ensure that a machine becomes available. Okay. So let's ask this question. So what's my most viewed video? So you saw that machine A kind of glowed up, right? So now machine A has got a session ID in its local runtime memory. Okay. So far, so good that there are two round trips that was done for this particular interaction. Now, let me ask another question. So you saw probably very quickly it happened because it's all real. When I clicked on give me channel stats, it actually went to machine B, but then machine B was not available. So it rejected. And you see here, like session B lost on machine B. But then because we have this client's scaffolding on, like it application owner worked with Cloud Run to ensure that whatever is the next machine available will be handled that, right? So that requires four round trips. So we as the end user will get the answer to whatever question we have asked. But if you look at the number of round trips, this is where it becomes interesting, right? So this is a 4x latency penalty and a 4x API billing cost to the application owner. Okay. And one more thing, right? If the developer forgets to really do the scaffolding well, then it becomes a problem, right? You actually will get a failed question. So let's say that we start with this and the scaffolding is off, it is going to get rejected. So it becomes very important for the developer to actually have this kind of scaffolding available. So now let's look at the new one. So the new protocol is actually 100% stateless, right, over HTTP. So every request will carry all required context. Let me ask this particular question. Whatever machine is available, it immediately answers that. And then again, look at the number of trips, right? Like I asked the second question, it just straight went to another machine, whatever was available. I'm keeping on asking like another multiple questions. So you can see that all of these are being answered by whatever machine is available, and you just have one particular round trip. But even for complex multi-turn workflows like confirming a video archive action here, MCP uses a sealed request envelope, right? So machine B asked the confirmation request, and then machine A actually completed the actual mutation. Nothing was held in memory between requests. So that is the real beauty of the new version of this protocol. And that's why I said in the beginning, it's a complete rewrite, right? So it's stateless and all of these things, which make it very powerful for the MCP developer, as well as, potentially if we are the users, we will see a quicker response and stuff like that, right? So I'm hoping that this video really made sense. The purpose of building this entire demonstration and really creating the MCP server to show you the different scenarios was to really explain to you what is happening under the hood and what exactly is the change. Because if you look at the blog, it provided the details, but then sometimes visualization helps a lot. Okay. So let me know in the comment section if you guys have any questions. And as always, if you're new to the channel, please hit that like button and subscribe. And of course, if you are an existing subscriber, please do let me know what you felt about this video and if you liked it or not. Well, look forward to your comments. Thank you very much for your time. Thank you for watching, and I will see you in the next one.